Alright, so in this video, we're going to look at what do the four parts of a linear rule stand for. So linear means that if we graphed it, it would be a line. What do the four parts of a linear rule stand for? So each linear rule has four parts. So y equals 7x plus 20, for example. So here we get four parts. So we have the y is one part, the 7 is another part, the x is another part, and our last part is the 20. So the four parts, and what do they stand for? So we know that x stands for our input, and we know that y is our output. But what does 7 stand for? And what is the 20? Where do those numbers come from? So let's say that I hire you to help build a garage in Quarryville. And I'm going to pay you some money to cover your gas, and I pay you for each hour. So here's your big question. Your big question is, as hours increase, what happens to pay? So choose the rule for your pay with x standing for hours and y standing for dollars. So you have a choice. You can either get $10 for gas and $9 per hour, or you can get $20 for gas and $7 per hour. So we're going to see which rule is better, and we're going to support our answer with a table. Okay, so hint, hint, using tables. So let's use our tables here. So if we choose 0 hours and we substitute 0 in for x in both of these because that's our input, we will get an output for the first equation of 10 and the second equation of 20. So here, the second equation is better. If we have an input of 1, we get outputs of 19 and 27. Second equation is still better. If we have an input of 2, we get an output of 28 and an output of 34. So the second equation is still better. If we have an input of 3, we get outputs of 37 and 41. Again, the second equation is still better. If we have an input of 4, our outputs are 46 and 48. So here, the second equation is still the better option. When we have an input of 5, our outputs for both of them are 55. So here, both of these equations are the same. So if you work for 5 hours, it doesn't matter which equation that you choose, you'd get the same amount of money. So then let's look at 6. So when we input 6 hours, we get back 64 and 62. So now the first equation is the better equation to choose. So why does this happen? Right? So why is this equation better at the beginning, the 7x plus 20? That one's better at the beginning because it has a better starting value. And why is this one, this 9x plus 10, better at the end, right? Because it has a higher what we call rate of change. So every time we increase our input value by 1, we are increasing our output value by 9 in our first equation and only by 7 in our second equation. And we call this a rate of change. So it has the better rate of change. So y equals 9x plus 10 has a better or a higher rate of change, and y equals 7x plus 20 has a better starting amount. So if we graphed these, so if we made our picture that represents these relationships, y equals 9x plus 10 is in the pink, and y equals 7x plus 20 is in the green. So we have our initial values. We've worked 0 hours. And then we have this point of intersection, which is where they're both the same. So they're both 5 out. When we work 5 hours, we would earn $55 from both equations. So what do the four parts of the linear rule stand for? Well, remember, x is the input, y is the output. The 20 and the 7, we need to figure out what those mean. Well, 20, if we work for 0 hours, we're definitely going to get $20. So we're starting out with $20. So this is our starting amount. And our starting amount is the output when the input is 0. Okay, so that's the value whenever our input is 0. And then the 7. So our 7 happens whenever we increase our input by 1, our output is being increased by 7. So this is what we call the rate of change. And this is the change in our output when the input increases by 1. So notice each time our input goes up by 1, our output goes up by 7, so our rate of change here is 7. So the 20 is our starting amount. That's the amount or the output when the input is 0. And the 7, or the number in front of x, which this time just happens to be 7, is the rate of change, which is the change in the output when the input increases by 1. So let's take a look at this. We have y equals 7x plus 20. This is what we call in a formula of y equals mx plus b. And this is a very important formula for algebra. And this is called the slope-intercept form. And it's called the slope-intercept form because the m is what we call our slope. Slope is the same thing as rate of change. And the b is our y-intercept. So it's where we cross that y-axis. So let's take a look at a few examples here. Farmer Boondin purchased 4 quarts every month. She started with 73 of them. So our rate of change, okay, this is our m. So our rate of change, notice how we're purchasing 4 quarts every month. So our rate of change is 4. We started with 73. So this number is 73. We're going to write a rule for quarts y after x months. So remember, our rule is going to be in the form of y equals mx plus b. So here our m is 4 and our b is 73. So our equation is y equals 4x plus 73. How many quarts will she have after 6 months? Well, now all we need to do is substitute 6 in for x in our equation. So we have y equals 4 times 6 plus 73. So y equals 4 times 6 is 24, so 24 plus 73, and then 24 plus 73 is 97. So she will have 97 quarts after 6 months. So let's take a look at number 2 then. So Farmer Boondin started with 111 tots on his farm. Every hour he destroyed 3 more of them. So the first thing we're going to look for here is our rate of change. So notice that every hour he's destroying 3 of them. This is going to give us a rate of change that is negative because we're losing tots every time. He's starting with 111 tots. So that's our start amount. And then we're going to write the equation for tots after x hours. So this is going to be y equals negative 3x plus 11. Because negative 3 is our m and our b is 111. And this could also be written as y equals 111 minus 3x. But we're just going to keep it as the y equals negative 3x plus 111. How many tots will he have after 5 hours? Well, here we would substitute this in for our x and then use our rule. So negative 3 times 5 is negative 15 plus 111. And negative 15 plus 111 is 96. So we have 96 tots after 5 hours.